Good afternoon. My name is Joanne Joins, and I would like to thank everyone for joining us today. Our webinar is designed for professionals in the pulp and paper industry to help their mills achieve sustainability goals and improve operations. Presenting today are Corey Abrams and Chuck Johnson. Corey is an application engineer with 6 years of experience at GORE. In that time, he has worked as a process engineer in GORE's medical and industrial businesses. He currently specializes in fluid sealing products and is responsible for application assistance, customer training, and product fitness for use. Chuck Johnson is an industrial markets field sales associate. He has been with GORE for 20 years and has specialized in fluid sealing products for his entire career at GORE. He is responsible for new business development, provides fluid sealing training, and provides application assistance recommendations to customers. Please post any questions that you may have during the training. The presenters in the chat. The presenters will answer any questions at the end of the presentation, or they will follow up with you by emailing following the presentation if the time runs out. One final reminder, this webinar is being recorded for future references. Now, I would like to turn it over to Corey to begin the presentation.
Thanks, Joanne. So today we're going to talk about how 100% GFO is a win for pulp mill sustainability and operations. GFO is a plug-and-play solution that can help pulp mills achieve significant reductions in power and water usage. In addition, GFO helps reduce packing maintenance time by 50% or more. At the end of this webinar, we'll talk about an opportunity to sign up for a free trial. So why are we talking about GFO? Well, operating a pulp mill requires lots of water and electricity. And it seems like these days, operations are always getting more expensive. At the same time, mills need to meet ever more stringent requirements and corporate sustainability goals. It seems like the goalposts are constantly changing. Fortunately, there is a simple and a cost-effective plant change you can make to help with both operations and to meet your sustainability goals. So as we're talking through this webinar, I'd like you to think about which of the following types of savings are most important to you at your mills? Is it power, water, maintenance, or a combination of those three? Or maybe there's something else that's highest on your mind. We're talking about this because pulp mills have hundreds of pumps. Pumps require a really effective seal to prevent leakage. Some pumps can use a modern dripless seal, but many cannot use that technology because there are applications that feature contaminants, which can cause catastrophic failure and unplanned downtime. This is something that mills will take extreme steps to avoid. Instead of mechanical seals, many pumps in pulp mills use an ancient technology called packing. It's funny, packing is a seal that's designed to leak. Packing can be made of a homogeneous material that's man-made or natural, like flax or acrylic, or it can be made of quite advanced stuff like expanded PTFE, the space-age stuff that goes into Gore-Tex, and it may include many variations of ingredients like expanded PTFE with graphite. Mechanical seals, on the one hand, are precision pieces of equipment. They need a pump to be set up perfectly to work well. They're complex. You can see how many different components there are in here. While they have extremely low emissions, they can fail catastrophically and are very complex to repair and replace. On the other hand, packing is a relatively simple construction. It's typically a braid of multiple fibers. It's got a low upfront cost. There is a small amount of leakage that's required, but it won't fail catastrophically, and it's easy and inexpensive to maintain. So the topic for today's webinar is packing. Now, packing can have a major influence on the amount of water and power that a mill uses. To dive in a little deeper, packing, as you can see here in black in the schematic and down here in this cutaway of a pump, is wrapped tightly around the pump shaft to prevent process fluid from leaking. But wrapping the packing around the pump shaft can cause friction. Friction increases the amount of power the motor needs to drive the pump, produces heat that must be cooled, and can wear down the packing or damage the pump, causing expensive replacement or repair. So what would a good packing do? Well, a good packing would reduce power by having low friction and a durable lubrication that not only reduces the amount of power the pump uses at one point, but over the lifetime of the packing. A good packing would be designed to transfer heat away from the shaft to require less cooling water to cool the packing. It would also maintain its shape so that the amount of water needed doesn't change over time. And finally, a good packing with low friction characteristic, good durability, good structural integrity or low dimensional change, as we just discussed, needs fewer and easier changeouts. Therefore, it requires less maintenance because it lasts longer. There are a number of different packings out there, and some have niche applications, as you can see. But paper and pulp is a 100-year-old industry. Numerous solutions have been tried. Over the last 40 years, paper mills have found that for most applications, PTFE graphite packing is the preferred packing type because it's the best performing and most widely applicable. Now I'm going to go into how PTFE graphite packings can vary because they can vary significantly. So let's talk about sealability, for example. Sealability defines how much cooling water will leak from the pump. Now, as you can see in this graph, there is a leader and a next best alternative. Let's see how that trend continues with other performance graphs. Next is retention of lubricant. As we discussed earlier, longer retention of lubricant means that you get the low friction characteristic of the packing that you're looking for a longer amount of time. Now, interestingly here, the next best performing lookalike packing is different than in the first graph. There's only one consistent performer so far, and that's 100% GFO. Both shrinkage or stability and creep resistance affect the dimensional characteristics of the packing, so how the packing changes shape. And again, you can see here that there's a clear leader and next best alternatives, but those next best alternatives are different from the lookalike packings we saw in the earlier graphs. Only 100% GFO has best-in-class attributes for each of these factors. Now, why is durability important? We talked a little bit about that in the last slide. Excellent durability ensures sustainability for the life of the packing and creates maintenance savings, and we'll highlight those maintenance savings here. In particular, we know that pumps can be smelly and located in difficult to reach areas, which makes maintaining pumps a chore and something that maintenance technicians don't enjoy doing that much. Now, lookalike packings can disintegrate and leave gunk stuck to the pump. It's like burnt food on a skillet that needs to be scrubbed and then soaked overnight and scrubbed again until you're not done, and so you buy a nonstick skillet instead. Cleaning a pump like this can take hours for your maintenance technicians, something that you don't want to have them spending a lot of time doing. The packing shown here, after third-party testing, disintegrated and left all sorts of gunk on the pump. In contrast, 100% GFO does not disintegrate. It won't harden, and it comes out as one solid piece. which means it's the easiest to maintain of all of the packings. Best of all, because it doesn't disintegrate, this means it actually keeps its performance properties. It's lasting for longer, and it gives you those benefits for longer. So the impact of improved durability is less maintenance, reduced water and power consumption for longer, so much so that 100% GFO packing typically lasts 2 to 3 times longer than the generic. Now I'm going to show a video of 100% GFO with the leading generic packing and the amount of water usage they each use. In this video, you'll see 2 pumps, and each pump is set up exactly the same way. So here you can see 100% GFO in a pump on the left versus the leading generic PTFE graphite packing on the right. There's a drastic difference in the amount of water leaking from these pumps. GFO, this might not look alike, but over the lifetime of the packing, for hundreds of pumps in a plant that sometimes are running 24/7, this amount of water leakage can really add up. GFO will maintain this leak rate throughout its lifetime, and because it'll last 2 to 3 times longer than the generic packing, that makes it the lowest total cost of ownership. So what you're getting is best properties in a packing over the longest amount of time to help your mill achieve both its sustainability goals and improvements in operations. So now I'm going to turn the floor over to Chuck to preview exactly what type of sustainability gains are possible.
Thank you, Corey, for taking us through the product differentiation slides. Now I'll share some information around metrics around switching to GORE GFO packing. Sustainability gains are not always easy to achieve. Investments in equipment can be expensive. Adapting processes can use a lot of company resources and be time-consuming. Often these changes require coordination on a plant-by-plant or with corporate. However, 100% GFO is a plug-and-play solution with minimal investment. Simply swap the current packing out with the GORE GFO and install using standard industry best practices. So by simply switching to GORE GFO packing, you can realize sustainability gains. This is an example of a typical pump used in pulp and paper. On the left, you have 3 metrics of power usage, water usage, and maintenance costs. This chart shows the yearly savings or gains by using GFO versus a generic PTFE graphite packing. So for power usage, you can see a generic ePTFE graphite packing used approximately 4,400 kilowatts per year. Switching to GFO on the exact same pump used approximately 1,800 or 1,900 kilowatts per year. So that's a 43% savings yearly. In regards to water usage, you've got the generic ePTFE graphite packing used close to 1,500 gallons per year, where the GFO cut that in half to around 7,700 gallons. So that's a 51% savings. With maintenance, typically with generic ePTFE graphite packings, you have frequent adjustments, and because they don't last, a lot of changeouts. You should be able to expect up to 50% fewer adjustments and 50% fewer changeouts, which directly will reduce your maintenance costs. Let's see how this same example translates into dollar savings. This example uses some of the assumptions that are noted below. While your costs may vary, the rising costs of incoming water and water treatment, electricity, and labor, we feel these estimates are conservative. The initial cost of the packing for generic was around $40. With GFO, it was around $65. So we were about $25 more. But just in power consumption, the difference in the savings was around $304 and more than makes up for the $25 difference in the initial cost. If you look at water consumption and maintenance, the savings really add up to where a typical pump with a 2-inch shaft, the yearly savings per pump is around $1,600 a year. If the site has 100 pack pumps, you could realize a savings of close to $162,000 annually. So some food for thought here. How do the savings shown in this presentation compare to some of those typically achieved by your projects at your mill? One other thing, we're the only manufacturer confident enough in the performance of our packing to print our branding on it. We have braiders that are involved in a seal of assurance program. All 100% GFO packing must have our printed name on it. This ensures the buyer is getting 100% GFO fiber and not a generic lookalike or a blend. So now we'd like to pause and see if there are any questions. Once done, we can share details on how easy it is to obtain a free trial. Corey, one of the questions that I typically get would be around supply chain, especially in today's world of supply chain constraints and with different materials. And so with GFO, we've been very fortunate that over the last several years, we've not had any supply chain constraints. We have 7 different braiders, or at least in North America, and those braiders typically have a large supply of GFO packing. So supply typically is not a problem, or availability is not a problem with our GFO packing.
Yeah, Chuck, I think that's a great point. I haven't heard of any issues either, and it's been highly available for our customers so far.
Great.
All right, I don't see any questions in the chat.
All right. So I'll move on to the details about the free trial. So GORE is offering a free trial of 100% GFO for the pulp mills. The QR code and web address on your left takes you to a form with 3 blanks: name, company, and best way to contact you. The QR code on your right is a link to our LinkedIn page. There you can follow along some of the trials, case histories, and questions. If you complete the 3 questions for a free trial, we'll contact you to get some basic information simply so we can send you the correct style or sized packing. We will also be sending these links in an email, and they will be placed in the chat. So that concludes our webinar for today. Thank you for attending. We'll be following up with you in the next 24 hours with information from today's meeting, as well as the links in the presentation, should you be interested in a free trial or an opportunity to learn more about GORE GFO packing. Thanks again, and goodbye.
Thank you.